Good morning, my dear students. How are you doing? Our lesson today, trigonometric substitutions, and here is this table that we're gonna use to solve the questions. The first question here, evaluate a radical 1 plus t squared over t dx. And as you see here, 1 plus t squared, root 1 plus t squared is the second expression here in the table, so we should use x equal a tan theta. Okay, so let's get started. Okay, step number one is let t equal, I will let t equals tan theta, and the dt equals the derivative of tan, which is secant squared theta d theta. So this should be dt. And then substitute in the question root 1 plus tan squared theta, and this all over tan theta, and instead of dt we're gonna write secant squared theta d theta. Okay, d theta here, and then the integral of 1 plus tan squared, which is secant squared, and root secant squared, which is secant theta, and this all over tan theta, times secant squared. I will write, instead of secant squared, I'm going to write 1 plus tan squared theta d theta. And then guys, here I will multiply secant theta over tan theta by this expression 1 plus tan squared. So we have secant over tan times 1 is stay the same, secant theta, and this all over tan theta, which is multiplying by 1, plus secant tan squared over tan. When you multiply this whole expression, secant theta over tan theta, multiplied by tan squared, I think that tan theta will be cancelled out with tan squared, and the remaining is secant theta tan theta. Okay, tan what? Tan theta d theta. And then here secant over tan, which is cosecant, because secant is 1 over cosine and tan is sine over cosine, so we can simplify this all by cosecant theta plus the integral d theta plus the integral of secant theta tan theta d theta. Then the integral of cosecant is equal to, I will complete here, I will write you my final answer here, equals the integral of cosecant theta d theta, negative ln absolute value of cosecant cotan. Yes, cosecant theta plus cotan theta plus the integral of secant tan, we know all, it's secant theta plus c. But we should complete here, guys. We should return the original value, which is t. So we will draw a triangle. Here is theta, and we know now that t equals tan theta, right? And tan is opposite over adjacent, so the hypotenuse in this case is 1 plus t squared. Okay, so the final answer will be over here, negative ln absolute value of radical what here? Cosecant Yes, and cosecant is 1 over sine, and we know that sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite, which is here the hypotenuse, t squared plus 1, and this all over t plus cotan. Cotan here is 1 over tan, and we know that tan is opposite over adjacent, which is t over 1. Now cotan will be 1 over t, and this all inside the absolute value, then plus secant, and secant is 1 over cosine, and cosine is adjacent over hypotenuse, so we're gonna write now the hypotenuse over adjacent, which is root 1 plus t squared plus what? Plus c. So this is my final answer. Okay, this is my final answer for the first. Okay guys, here in this example, which is evaluate the integral of 3x cubed over root 1 minus x squared dx. Okay, let's here change the color and solve this question. Root 1 minus x squared. Yes, root 1 minus x squared. Yeah, 1 minute please. Yes, like that. Okay guys, here in this example we will use, I'll write it over here. I will check the space. Yes, we have a lot of space, so no problem. We will write x equal sine theta. Sine what? Sine theta. And dx now equals, dx equal the derivative of sine, which is cosine theta d theta. And then substitute by this value dx and the x in the question. Yes, let's substitute here. The integral of 3x cubed, so it will be 3, and the x now is sine cubed theta, nice, over square root of 1 minus x squared. X squared now will be sine squared theta dx. Dx all will be cosine theta d theta. This is the substitution, our first step in the substitution. Okay, we know that 1 minus sine squared is, yes, 1 minus sine squared is what? Yes, I hear you. 3 sine cubed theta, the same, but over in the denominator we have radical 1 minus sine squared theta, which is cosine squared underneath the root, and outside the root will be cosine theta, right? 1 minus sine squared is cosine squared, and the root of cosine squared is cosine theta only. Okay, times here cosine theta d theta, right? Nice, we can cross out cosine theta as cosine theta, and the remainder is 3 as a constant, and then we have sine cubed theta d theta. And I think that we have started this lesson before. What's the rule we used here? Yes, we can split sine cubed as, we can split it as sine and sine squared, right? Sine theta and sine squared theta. Okay, and this to the respect of theta. Next step here is what? To replace sine squared by 1 minus cosine squared theta, and then multi-distributive property. We cannot use distributive property, so let's write again here 3 and then sine theta into sine squared will be 1 minus cosine squared theta d theta. Okay, and then use substitution method. What is the substitution method? Yes, we know now. All of you know the substitution method now. We will let u, z, any variable, stands for cosine theta, and the derivative is negative sine theta d theta. Sorry, the derivative here is, okay, this is the derivative, which is du equal negative sine theta d theta. And use this stuff and substitute in the question the integral of sine theta 1 minus u squared. D theta now is du over negative sine theta. So we write here du over negative sine theta, and cross out sine or sine, and we have negative 3 now. This negative will be outside the integral, and then 1 minus u squared du. Final answer is negative 3u, and then positive u cubed over what? It should be 3u cubed over 3, and cross out 3 with 3 plus the c, and then return back your variable as cosine. Negative 3 cosine theta plus cosine cubed theta plus c, and again return your variable back to its original, which is x. And to make this, we should draw the right triangle. Here is the theta, and we know that x equals sine theta. We said like this from the beginning, and x equals sine theta, so it's over 1. So sine theta is x over 1, which is opposite over hypotenuse. And so the third side here will be 1 minus x squared. Substitute here, guys, negative 3, and cosine is adjacent over hypotenuse. Adjacent, which is 1 minus x squared over 1. I will not write it. Cosine cubed, again 1 minus x squared over 1, and this all to the power of 3 plus the constant. This is our answer. Okay guys, here in this example, evaluate 5x cubed root 1 minus x squared. Our substitution here will be x equal, our substitution here is x equal sine theta, and sure dx equal cosine theta d theta. Okay, then substitute by this business in the question here. So we have the integral of 5, and the x will be sine to the power of 3 theta root 1 minus sine squared theta, and dx is cosine theta d theta. Next step is 5 sine cubed. I will leave it the same, but here 1 minus sine squared, which is cosine squared, and outside the root will be cosine theta, and 1 more cosine theta outside here. So in the next step, they all will be 5 sine cubed theta times cosine squared theta d theta, right? Okay, and the next step here, yes, we will use substitution, but here I will let u equals cosine theta, and du equals negative sine theta d theta, and d theta is equal to du over negative sine theta, and use this all and substitute here. 5 sine cubed theta times cosine squared, it's u squared now, times d theta, which is du, and this all over negative sine theta. Cross out sine theta with the sine squared, with sine cubed, we still have only sine squared. So what? Yes, we still have only negative 5 integral of sine squared theta times u squared du. Oh, we have sine and du. We have sine theta and du. what should we do here? Yes, sine squared can be written as 1 minus cosine squared theta times u squared du, and cosine squared will be now u squared, right? Negative 5 integral of 1 minus u squared times u squared du. Okay, and then equals negative 5 the integral of u squared times 1 u squared du minus, it will be positive 5 now, negative 5 times negative is positive 5, the integral of u to the power of 4 du equals negative 5 u to the power of 3 over 3 plus 5u 5 over 5 plus c, and cross out 5 with 5. Okay, we should return back, guys, this to its original. How? We know that the u is cosine, so it's negative 5 over 3 cosine theta to the power of 3, right? Cosine cubed theta plus cosine to the power of 5 theta plus c. And to return again this to its original variable, which is x, we will draw a right triangle and here theta, and from the beginning we will let x equal sine theta. Yeah, so x over 1, so opposite over hypotenuse, so the third side will be 1 minus x squared. This also easy, and you have studied before. The final step is to write your answer as negative 5 over 3, and the cosine now is adjacent over hypotenuse, which is root 1 minus x squared over 1. This all will be to the power of 3 plus again 1 minus x squared, and this all to the power of 5 plus c. So you should leave your answer in terms of x. Okay, guys, here exercise 2 exercises. We will use trig substitutions and completing the square. So in this example, evaluate the integral of ex over root 1 plus ex plus e to the power of 2x. Yes, all of us in the previous example, in previous video last week, learned how to complete the square. We should add b over 2 all squared to each side. So here, what should we do here, guys? What should we do here? We should complete the square. So here, guys, first of all, we will use substitution. Why substitution? You will see now, guys, why substitution. Bismillah. First of all, I will let u equals e to the power of x. To make the numerator 1. Why substitution? To make the numerator 1, not e to the power of x. And now du equal the same. The derivative of e to the power of x is e to the power of x dx. And then dx is equal to du over e to the power of x. I will use all this business and substitute in the question, which is e to the power of x over root 1 plus e to the power of x, which is u, plus u squared now, times dx, which is du over e to the power of x, and then cross out e to the power of x with e to the power of x. Okay, and then we will, step 2 here is to what, guys? Complete the square. And to complete the square, we will add b over 2 all squared. And how to complete the square of 1 plus u squared, or u squared plus u plus 1? I'm gonna add b over 2 all squared. 1 over 2 all squared, and then plus 1, and then subtract 1 over 2 all squared, which is u squared plus u plus 1 over 4 plus 1 minus 1 over 4. Since you add something, you should subtract it again to keep the same meaning. So u squared plus u plus, what do we have here? Plus 1 over 4. I will put it inside one parenthesis. And 1 minus 1 over 4. What's the answer? 3 over 4 plus 3 over 4. the same. I will use only the last step, or we can complete here. How to do it? U squared, it will be u plus 1 over 2, and this all to the power of 2 plus 3 over 4. Nice. And then I will substitute here in my question 1 over root u plus half, and this all to the power of 2 plus 3 over 4 du, or let the du in the numerator. Okay. To make this question easy, I will use substitution again, but here to make it easy, I will use a variable stands for u plus half, any variable. So let's use, for example, I will complete here. So the integral of 1 or du over the square root of 1 u plus half, I will let it z. I will let it what? Z squared plus 3 over 4. Okay? It will be z. So when u plus 1 half, when u plus half is z. So what's the derivative here to change the u also? So dz equal, it's 1 du, right? And again du is dz, so du will be dz, and we can replace here the du by dz since they are the same. And then use trigonometric substitutions, which is our lesson. Which is our lesson. What is the z? The z equals radical 3 over 4. This part should be perfect square. So to make it a perfect square, it could be radical 3 over 4, right? Yes, it will be, it's a 3 over 4. It's as a squared. So what is a? Only take the root for each side, which is radical 3 over 2. Radical 3 over 2. So this part is 2, not 4. Radical 3 over 2 tan theta. Why tan theta? Because it's a variable squared plus a perfect square quantity. It's a squared here plus it's a variable squared like z squared, x squared, anything squared plus a number raised to a power of 2. So it's a tan theta, and dz, the derivative here is radical 3 over 2 as a constant, and the derivative of tan, which is secant squared theta, d theta, right? And substitute in my question, which is, what's the final step here? This one, the integral of dz, and dz now, which is radical 3 over 2 secant squared theta d theta, and this all over root z squared. The z squared, which is radical 3 over 2 tan theta, will be now 3 over 4 tan squared theta plus 3 over 4. We can now, guys, take 3 over 4 as a common factor from the denominator. If we take it here, so we have radical 3 over 2 secant squared theta d theta, and this over 3 over 4 3 over 4 as a common factor, 3 over 4 common factor, so we have tan squared theta plus 1, this all under the square roots. 3 over 4 outside the square root will be radical 3 over 2, so we can cross out radical 3 over 2 with radical 3 over 2. And the next step will be the integral of secant squared theta over secant theta. Why? Because tan squared theta plus 1 is secant squared theta. What's the root of secant squared theta? Is secant. And we have in the denominator secant squared theta over secant theta. So when we have secant squared theta over secant theta d theta, okay, we can cross out secant with what? Secant squared, and the remaining is the integral of secant. And the integral of secant is so easy, which is secant theta plus what's the integral of secant? Yes, the integral of secant, which is ln absolute value of secant theta plus tan theta. Yes, and we proved this. before plus c, but you should return back your what variables, and this is the big deal here in this question, or big issue. We should, guys, return first the tan theta to u and the u to what? We should return this theta to z, sorry, and the z to u and the u to e to the power of x. Take care. So pay attention from here. This is my final answer? No. This is the answer in terms of theta, and we should return our variables back again to its original. So here I'm gonna complete here, guys. In this page I have ln. I will write the answer here. Ln absolute value of secant theta plus tan theta plus c, right? Okay. First step is to write tan theta. Tan theta is equal to what is tan theta? Tan theta, from the beginning of the question we let tan theta here is equal to, yes, tan theta is here, is equal to 2z over radical 3. We can write a relation here, which is tan theta is equal to 2z and this all over radical 3, and use this value over here. Tan theta is 2z and this all over radical 3. Okay, and then draw a triangle. I'm gonna draw here a triangle. Here is the theta, and we know that tan is opposite over opposite over what, guys? Opposite over adjacent. So the opposite will be 2z. But we have secant. Yes, so it's 2z over, yes, the secant. Now we have secant theta. It's 2z, sorry, over radical 3. So here the radical will be, the hypotenuse, sorry, is the squaring of these two sides, yani 3 square, 3 only plus, yes, plus 4, we will write 4 like this, plus 4 z squared, correct. And then return back again, guys, here. We let from the beginning here z equal tan theta, and tan theta is 2z, and we said that z is equal to what here? U plus half, right? Every z is u plus 1/2. So we know that every z is u plus 1/2, right? So here this part will be at the end the ln, absolute value, take care. U plus half is the z. So what is secant theta? Secant, which is 1 over cosine, and cosine is adjacent over hypotenuse. So adjacent, which is root 4, and z, which is u plus half, and this all to the power of 2 plus 3 over the hypotenuse over adjacent, and the adjacent is radical 3. Nice. Plus tan is opposite over adjacent, which is 2z, and z is u plus half over opposite over adjacent, radical 3, plus c. We didn't finish, I tell you. We should do one more step to return the u to x. Yes, we will go back again to the beginning of the question. We know that u is e to the power of x, so I'm going to replace every u by its value. So since u is e to the power of x, so my final answer is ln absolute value of square root of 4 into e to the power of x plus half, and this all squared, plus 3 over radical 3 all, plus 2 over radical 3 into e to the power of x plus 1/2 plus c. This is the final answer of this question. Okay, thank you guys, and hope you understood everything. Goodbye.